1 from the functions test. We have a graph of a quadratic function, y is equal to f of x, is given below. Write down the equation of the axis of symmetry. Now, if you have a look at this, if you had to draw this axis of symmetry, it would be the point which is halfway between, it cuts this graph exactly in half. So we can often use our x intercepts to find out where that is, because you've got -2 there and you've got 8, so the whole distance there is how much? What is the whole distance from there to there? From 8 to -2? It's 10. So it'd actually be 5 would be halfway in between. So it would actually be at 3. And if you draw down here, you see that that's cutting the graph in half. So you've got this line, when it says the equation, is because you've actually got a line down here that's going, and that line is x is equal to 3. These lines that are perpendicular like that, they cross across the x-axis perpendicular, we call them x is equal to. If you've got a line that's perpendicular to the y-axis, like if I drew a line along there, what would the equation of that be? This is -10 here. Y is equal to -10. Alright, so write down the equation of the axis of symmetry, x is equal to 3. Okay, so we've got that. Then it says, write down the coordinates of the minimum points. So you've got to write down this point over here. So in looking at it, you know that your x is going to equal 3. Your x will equal 3. What will your y value be? Well, it's between 10 and 15. Each one of these is equal to 1. So it would be 14, but it would be -14. So you've got there 3 and -14. And then looking at the range. Now what is the range? Yeah. Range where to where on the y. Alright, so from where does it start? What's its starting point? Its lowest point, if you go here, is -14. So it's just y is greater, or it can be equal to -14. Okay. Alright, so that's 6 marks for that one. Okay, Anthony, that's all pretty within, you've seen all of that before. Eh? So we've got the range, that's from where to where on the y-axis. For your x, what do we call it? What do we call it when we're looking at the x? The domain. Okay, good. So alright, going to this one here. Okay, so you've got this graph. F of x is equal to a sine of bx plus c, and this is shown from 0 to 360. Write down the period of f of x. What does this term period mean?
How many times there's a cycle within 360?
Yeah, it's the number of degrees to complete one full cycle. So if I drew one full cycle from here, this would be a full cycle. You see, I'd go up to there. From then on, I'm starting to repeat what I've done before. So it's up to there. So it's this point over here. So it would be the period of f of x would be that's going to be, what is this? This is 90, 180. It's going to be 180. All right? You okay with that? Write down the values of A, B, and C. Now, you need to know what these things are. We investigated these somewhat. A is what? What is A? Amplitude. The B, what do we get from the B? Alright, the period is equal to 360 divided by B. Okay? And the C is the y shift. How much you shift in the y-axis. So looking at that then, what is the amplitude of this graph? What is the amplitude? So basically your amplitude is from your middle position. So if I redrew this, is from your middle position, that middle line, either up or down to the maximum. So that would be your amplitude there. So it corresponds to 4. Okay. Sorry, you got to. Oh no, it's not 4. Sorry, it's, what is it? 3. Because you see we're starting at 1 already. So your amplitude is from 1 to 4. So it's going to be 3. Sorry. Did you get it right? Okay, I'm going to change it. Yeah. And I marked it right. Okay, good. All right, B. You want to work out B now. We already know what the period is. It's 180. And that's equal to 360 divided by B. What must B be? 2. And how much of a shift is there in this graph? How much has this shifted? Usually, that's right, it's shifted 1. Usually this graph would look something like this. It would go up like this, and then come down to this, and would be up like this, and it would usually look like that. So it's all been shifted up 1. So your C is going to be 1. Okay. And then, alright, so we all okay with that? And then finally it says the number of solutions to the equation f of x is equal to 3. So we've got this graph over here is f of x. And want to see how many times is it equal to 3 between 90 and 270. So we're looking at this range over here from 90 to 270. We're not interested in this over here. We're just interested in that section there. Now we've got f of x is equal to 3. So what I do is I draw a line, this line over here, f of x is equal to 3. This is f of x is equal to 3, that line going through the 3 on the y-axis. And we see how many times it crosses over. It crosses over once, twice. Because it says here it goes from 90 to 270. So I've crossed those out. We're not interested in that, but we're only interested in this part from 90 to 270. It's 2. There'll be 2 solutions. They weren't actually asking you for the solutions, just the number of solutions that you would have.